Hello, everybody. My name's Michael Getz. You saw me briefly to discuss chemotaxis, but I am back today to discuss uh, mainly how to extend CompuCell3D. And unfortunately, to extend CompuCell3D, you need to learn how to compile CompuCell3D. For most of what I will be covering today, uh, you can find this content in the CompuCell3D developer manual, which I have linked here in the slide. I can try to put it in chat. Okay. I need to actually leave this one. Let's go up here and I can give you guys this link immediately. So this will be very useful if you fall behind, which is likely because I can't exactly wait for everybody to try to compile this. It can be a bit ornery, and the kind of the errors can be very small and differ between cases. I also put the links to the hackathon, idea sharing, and the workshop Slack as a reminder. This module is live streamed and will be distributed on YouTube. So for the first half, I'm going to mainly focus on compiling CompuCell3D. If I get through that very fast, I will start to cover what I have as module 9.2, which is making plugins and steppables. These are different from the steppables that you guys have been using. Not really. It's just the same idea of the steppable, but it functions on the C level. The main reason is for speed. So today, for the first part, I will be trying to convince you why you even want to extend CompuCell, and then how to compile CompuCell and then go through the steps of what is needed, then show in my system, which is Windows, what the solution looks like when you've compiled it. Unfortunately, I only have a Windows, so for Linux or Mac environments, I can't directly show it. Although for some of these steps, I did put what you need to do for Mac and Linux, but a complete documentation of how to compile Mac and Linux environments are also in the link that I put in chat. So why would you want to extend CompuCell3D? Well, mostly it's speed. The Python versus C in terms of the evaluation is, I think the metric people normally use is about 10x. In addition, by going at the C level, you are able to access the energy functional or a lattice monitor, which basically means you don't have to wait for the MCS to stop to influence the system. You can do it while the system is undergoing the Metropolis function. I wanted to make an image, but I could not get that in time. I'm sorry. So the biggest thing is speed, number one. And then number two is that we can now extend the energy functional, which is how we set up the pixel flip probabilities. Or we can put what is called a lattice monitor, which basically checks how the CompuCell lattice changes. Which checks how the lattice monitor changes if you wanted to do some function on that in the sub step and not have to wait for the MCS. So in order to compile CompuCell, there's really three main things. You need a copy of CompuCell3D's core code through Git. I I will be using, or we will be using 4.6 in these examples, which is if you go to the GitHub, it's currently the default path. You need Miniconda or Anaconda. I have Miniconda. And then you need some sort of compiler. And of course, there are some major differences for the compilers in the step, mainly between Unix and Windows environments. For this module, again, I will be focusing on Windows because that is what I am using. But I will briefly cover how to set up the Linux and Mac environments. So the easiest step and probably the first step is you need to copy the CompuCell3D GitHub repo. So there's a couple minor differences in how you would do this. If you do eventually want to try to contribute to the core CompuCell3D core code, you would want to first fork the repo and then clone from your own forked repository. If you do not want to contribute to the core code, that's perfectly okay. You can just, oh, okay, sorry, poll came up again. You can just clone the repository directly. It's the same thing. It just, you won't have a fork to then try to merge into CompuCell itself. That is perfectly fine. That is normally what I do for my small edits in my projects. So you'll have to pick some path. So, CD, some path, you have to go to that location, and then you just can run git clone and then the git address. If you don't want to do any of that, you can always just download the zip file from the GitHub and unzip on the local PC in this sum path. It's important to know where this sum path is. And sum path is literally sum path in the situation. And Maciek makes a good point in the chat. For a lot of these small issues, your LLMs, ChatGPT, DeepSeek, do a very good job at trying to help you out, help you solve the solution, or help you write your boilerplate code. So the button for the fork, if you don't know where it is right here. And then on the website, if you just want to download if you click on the code, it'll do a drop-down menu, and then you have download zip. Or you can see the git address that you would want to run git clone to. So the next thing you would need is a compiler for Linux. Congratulations. You already have it. I put a note here for the OpenGL options in terms of how to target them. With the note that the two that I have listed work only in Ubuntu environments. I don't know if this statement is exactly correct, but you would have to adjust it if you were running some different distro like Red Hat. If you know better solutions, please let us know. For Mac, you will just need to run xcode select install, which is just putting the OS X core developer tools. This may take some time to do. In Windows, this definitely takes some time to do. You will need to get either Visual Studio 2015 or 2019 Community Edition, with 2019 being preferred for speed in compilation. There's an important note when installing this, the Visual Studio 2015 or 2019 Community Edition, that you want to make sure desktop development with C++ is selected. If you have already installed it and you did not select desktop development with C++, you can always do this after the fact by opening up your Visual Studio, going to Tools, Get Tools and Features, and then you will see a pop-up where you can then select desktop development with C++, and then install. The biggest thing is this will take some time. The desktop with development with C++ package is rather large. I think it's about 7 gigabytes. So it can take some time to download. As a quick poll for those of you here, who has a compiler available currently that they could attempt to do this with? This will generally set some of the speed going forward. If you don't, it's perfectly okay. You just, for the later steps where we do the plugins, you can write them. You just won't necessarily be able to test them out in the player output. So I can show you, go to Visual Studio. If I want to check to make sure I have it, I do Get Tools and Features. It'll open this. And then you can see right here, desktop development with C++ is selected. That's what you need to make sure you have in the Windows environment. Other steps. So the last thing you will need is you need to get the compilers for CompuCell using Miniconda. So there's two ways to do this. One is you have CompuCell3D Mamba installed. The caveat is that you will be changing this install. So the changes that you do to the repo that you then compile on will change your version within the environment, right? So that's why the first thing we do is we create a specific environment to do these edits in, because this is where we are creating our custom version of CompuCell. So if you are installing it, it's the same that was done before. You just kind of create new, the name of your environment, and then we want to lock our Python version to 3.10 because we are using 4.6. We can then activate the environment, make sure Mamba is installed, and then run the Mamba install, making sure to select the 4.6 package. So this will take some time. The biggest benefit of doing it this way is then you don't need to worry about Twedit or player repositories, because it will be kind of prepackaged by installing the whole. If you just want to install the compiler options, you can do this instead, which you create a Mamba environment, and then you target a YAML file. I have So for your information, I think I skipped that slide, sorry. So a YAML file is just this. It tells you what channels it wants to use to get these packages, and then dependencies for these packages. I put a YAML file for every operating system here. If you want to do it this method, those YAML files will set up the compiler environment. So all you need to do is target that YAML with at this point in your command, and then you can then activate that environment name. This will effectively set up the environment. Doing a test, setting this up took me about 6 minutes to get this environment name. So between option 1, installing Conda, and just setting up the compiler environment itself, they both took some significant time for Conda to resolve the environment. Because it takes so long, I unfortunately will not pause here to let everybody keep with me. I will, at the end, make sure there's enough time. So if somebody does want to do this, I will answer questions and go back through some of these slides to try to get your environment running. But as I said before, some of these issues that you can hit with setting up these environments can be very specific to your issue. So it's easier to kind of let everybody run at slightly different paces depending on how their environment wants to resolve. Okay, so this part is very ornery to make it simple. What you're doing in this section is you're just setting up your CMake command. When I say these are very exact, I mean very exact. Spaces, you have to put the right dashes. If you run the CMake command and it does not seem to work, or so one of the issues I had while running through these files really quick was I put the wrong dash in front of the dash B, which targets your build files. So it would just create a folder called dash B and then put my build files there. So to be unfortunately, you have to kind of run over this command with a fine-tooth comb to make sure it runs correctly. So what you're doing here is you're targeting your source, you're doing your path to your CompuCell repo clone, and then going one folder in to the CompuCell3D folder. You're targeting some build files. This can be really just any folder that you want to put the build files in. We are targeting our Python executable. And then we have some options that I will gloss over for now, the DNO OpenCL on and dbuild standalone off. This is targeting our compiler itself. For me, it's Visual Studio 16 2019 because I have Visual Studio 2019. And then DC make install prefix. This again is just some directory that you want to write the install files to. The more important ones to focus on are the build file location and the making sure the source files are correct. I will show you what this looks like for my computer on the next slide. For Mac and Linux, it's very similar. The difference is just in the your -G option, which is your compiler. For Mac, you're going to use Unix makefiles. And then Linux, well, you're doing the same thing, but you have to target your OpenGL GX library. Okay. So for yes, and as Pedro said, when you get this CMake command to work, just make a text document, save it. It makes your life a lot easier if you ever have to reset up the environment because it is, as stated, very ornery. So for my CMake input, I target the a version of source code, a build directory that I've set up, and then my executable location. So in this example, I am targeting the environment CC346 through 10, and then targeting the Python executable within that environment. As said before, I have 2019, and then this is just some install project location. Right. When you run this command, this command is actually relatively quick because it's just setting up the configurations, generator, and then it'll tell you where your build files have been written to. Make sure you check this. As I said before, I had a small typo. I've had a small typo before in this, and it would write to F, and then it makes a folder -B, which is not quite what we want. So if I show you on here, so if I haven't cleared the demo, yeah, so you can see the targets right here. So this is a version of, this is my copy of the repo. This is the build files that get generated. And then here is install project, which is currently empty. Okay. So now if we want to try to compile the solution on Windows, you are going to use Visual Studios again for the other operating systems, Linux and Mac. Please use the developer manual. It is actually easier on Mac and Linux because you just run a make and make install command along with a couple extra steps. So I will show you here. So this is what my environment looks like. Don't worry about these open files. What I want to bring attention to is the Solution Explorer at the end. So first, let me actually take a step and show you how you would open it. So you do open project solution, and then you can just target your build file. So for one of the examples, so for this one, I'm going to just target this, which is the one I have open. So you want to open your all build bcxproj file. When you open that solution, it'll take a couple seconds. You'll see a bar run, and then your Solution Explorer will be up. So if you only want to compile and you don't want to, if you only want to compile and you're not doing any edit to the system yet, all you need to do is go to all build. You can select build. For me, I'll select build. I've already built the files, so it's just going to tell me everything's up to date. And then once you get this statement, if you're building all the files from zero, it will take some time. So be prepared for that, and it can, depending on your computer, it can hang it for periods of time, or hang Visual Studio for a period of time specifically. Then once you know that you have all build complete, you can then install. So what build does is it basically populates your build folder, and then what install does is it then moves it to your environment. So if I run install, you can see it's telling me the build started, and then you'll see a whole bunch of text go through, basically checking to see whether the linkers in the Python environment are up to date, which they will be. And then it will give me a similar build once exceeded 83 up to date. Right. So I have some of these images on the slides to kind of help you out. There's a note when you have your solution pane open, you can access the source code from this pane. So say I want to look at open the CPP files for the Chemotaxis plugin, I can just find Chemotaxis shared, expand out the tree, and then double click on the Chemotaxis plugin. This is
Sorry,
an
Go ahead. Did you answer the question about which build button do they need to hit? You say all build here?
Yes,
There's a question in the chat.
It is all build. The only two that you necessarily need to run first is just all build, which tells it to build all of these, except install, and then run install after you run all build. Okay. Let me know if that was not sufficient of an answer. Oh, okay, I see. Yeah, so what you want to do is right click on all build, right? And then you'll get this menu, and you can select build. Then once you get the confirmation, I'll do it here because it's just going to tell me everything's up to date. Right, once you get that confirmation that it's completed the build, then you can go to install, similarly right click and then build. There's a word of note. If you're editing a plugin specifically, you don't need to make the effort to do all build. You can go to that plugin. So let's say I was changing elasticity. You can then go there and then do project only, and then build, rebuild, or clean it. Clean just means it's going to rebuild means it rebuilds. Clean, it will remove what it has made, and then build builds. But if build sees something cached, then it's not going to try to build again. So an important thing that I didn't discuss is right here. You have this drop down. By default, it will be on debug. Before you do all build, you need to set it to either rel with dev info or release. I always keep it on release because I get less errors for some of my specific use cases. This is mostly because Windows can become very upset with the debug, running debug because of the Python linkers, because Windows doesn't necessarily understand what's going on there.
So,
right?
So just to chime in, this happens only on Windows. If you want to compile in debug mode, you need to have debug version of Python libraries. And this is the tricky thing to get. If you are on Linux or on Mac, this issue does not exist. And you can compile in debug mode on those two platforms. So I would encourage people to explore those two platforms, in addition to Windows, of course. But if you're building just simple steppable, you probably don't need debugger. You'll be fine. And whatever Michael is showing will apply to your case.
Yeah, thank you, Maciej. Yeah, exactly as he said. For most of the use cases, you're fine to do this, but you can effectively debug, of course. Right, you need to not be on Windows. So as I said, you can build all builds. You can get some interesting issues when you do try to build. Please let us know if you hit one when you try to build it. If I can answer the question, I will try. Right, and then you can, once you know it's complete, you can build the install. Again, for other OS compilation processes, please see the developer manuals. For the most part, it is just a make install. The homework that I will give, because it would be hard to kind of have everybody trying to compile their on their systems, is for you to try it yourself. The developer manual is very good at kind of walking you through the steps. So if I haven't made it clear, hopefully on the developer manual itself, it can do a better job. We are always open for questions if you do kind of hit snags while trying to set your environment up. There is an important note here. If you're running Mamba and you see permission errors, I had to do this. You need to elevate your command, or in Windows, run in administrator mode before to allow it to install these files. But before activating this environment, try to remember to return to normal permissions. So I'm going to start. So if this is done correctly, you should get install on Windows. So the environment that I built to was actually CC3D 4.6. I can now do the command that you guys have seen before. Python-m cc3d.player5. This will open up player from Anaconda. There it is. All right. So I have a simulation that I've named simple simulation, which is just cells with no no constraint getting generated at the center. So you can see that I have a compiled version of CompuCell there. And it is doing what I told it to do, which is make a whole bunch of cells of two cell types and just exist with no constraints. Okay. And similarly, you can always open Twedit to make sure that opens too. If you want, you can test to make sure you can open a project. So here's simple simulation. Right. Okay. So at this point, all you've done is compile CompuCell. You've just made sure that you can make the C code runnable from your Python environment. Now, because you can do that, well, basically, you can just start editing the C code if you want. The key word on that is if you want. There is a good way to just extend it naturally without having to go and edit the C code itself, which is what we will cover in 9.2.